In this video, we will find 4 methods for solving 2 equations with 2 unknowns. Here we have the standard form for a straight line y is equal to mx plus b. This is called the slope-intercept form. M is the slope and b is the y-intercept. First we plot b on the y-axis, then the next point we plot using the slope. The slope as a fraction is equal to the change in y over the change in x. Now, if we look at the blue dot on the y-axis, that dot is at y equal 1. That's the y-intercept. If we go up 2 steps and then over 3 to the right, that's our next blue dot, and there's a blue line connecting the 2 dots. The other way to plot a straight line is to set up a little table, and we need to only do 2 points. So in the table in red, if we let x be 6, we have 2/3 times 6 plus 1. 3 goes into 6 2 times. 2 times 2 is 4 plus 1 is 5. Okay, so we plot the point 6, 5. So we could start at the origin, 0, 0. We go over 6 steps to the right, and then we go up 5 steps, and we see a red dot. We can now put in 9 for x, then 2/3 times 9. 3 goes into 9 3 times. 2 times 3 is 6, plus 1 is 7. So we go over 9, go up 7, and we put another dot, and we connect to red dots. And of course, this is the same line. So to do a table becomes somewhat tedious. Most people would rather use y is equal to mx plus b, because the first thing you do is put b on the y-axis and then use the slope to find another point, and you have your straight line. In this example, y is equal to -4 times x plus 3. -4 is the slope. We will write it as a fraction. M is equal to -4 over 1. The number 3 is b. That is our first step. We plot on the y-axis a dot at 3. Now we use the slope. We go down 4 steps from this point. That would bring us down to -1, and we go 1 step over, and we put another dot, and then we connect the 2 dots with a line. Notice, as you look at the graph from left to right, a negative slope will produce a line that goes down. In this example, y is equal to 1/3 x minus 2. 1/3 is already a fraction. First step, put a dot at -2 on the y-axis. Now, m is equal to 1/3. Go up 1 step from -2. That puts us at -1. Go over 3 steps to the right, and there's another red dot. Starting with that dot, go up 1 step. Now we're at 3 on the x-axis, and go over 3 steps, and we see a blue dot. Start with the dot at -2. We could change 1/3 to -1 over -3. We go down 1 step, and then over to the left 3 steps, and we see a purple dot. In this example, we have y is equal to the mixed number 2.5 times x plus 1. We will change 2.5 to an improper fraction. We do 2 times 2 is 4, plus 1 is 5 over 2. The y-intercept is 1. Put a red dot at 1. We'll go up 5 steps on the y-axis. That would bring us up to 2, 3, 4, 5, 6, and then go over 2 steps to the right, and there's another red dot. We'll change 5 over 2 to -5 over -2. So we start at the red dot at 1 on the y-axis. We go down 5 steps. That would bring us down to -4 on the y-axis, and go to the left 2 steps, and there's a purple dot. This example is very different. It does not fit the form of y is equal to mx plus b. X is simply 4. Now, you see the 2 red dots. When y is 1, there's a dot that x is 4. When y is equal to 5, there's a dot that's 4 units over. And if you connect the 2 dots, you get a vertical line. Vertical lines do not have a slope. And these are the only type lines that you can't put into the form y is equal to mx plus b. In this example, we have two lines. One equation is y is equal to 1/3 times x minus 2, and the other one is y is equal to 1/3 times x plus 1. The slopes are equal. They slope the same way. So with the first one, the y-intercept is -2. The slope is 1/3. We go up 1, go over 3, and that's the red line. The second one, the y-intercept is 1. We go up 1, go over 3, and that's the blue line, and they are parallel. So we can say if two lines have equations where the slopes are equal, the lines are parallel, and if two lines are parallel, the slopes are equal. In this example, we have two lines again. The slope of the first line is 1/3, and the slope of the second line is -3. If you multiply 1/3 times -3, the product yields -1. So if two slopes are such that when you multiply them, you get -1, the lines will be perpendicular. And we see y equal 1/3 minus 2, that line is in red, and y is equal to minus 3x plus 1, that line is in blue, and those lines are perpendicular. Now, a vertical line and a horizontal line are perpendicular, but you can't say the slopes are equal to -1 when you multiply them because a vertical line does not have a slope. Likewise, two lines are parallel. They have the same slope, but you can't say two vertical lines have the same slope because they don't have any slopes, but they are parallel. That's two vertical lines. Here we have some examples of straight lines, and y is equal to minus 3x plus 1. That's an equation that represents a straight line, and it's in the form y is equal to mx plus b. The same for 2x plus y equals 7. It can be put in the form of y is equal to mx plus b, and the same for 2x minus 5y is 12. Notice that each one of these has an x and a y, and they're separated. Now, what are not straight lines? If we look at the first one, it has an x squared in it. You could have an x cubed, x to the 4th, x to the 5th, not straight lines. 2xy equals 7. That's an equation that does not represent a straight line. The x and y are together. And then we have 1 over x minus y is 2. The x and the y are not together, but it's 1 over x. It does not represent a straight line. Now this ends our review of the mechanical parts of straight lines. So that was how to draw them. Are they parallel? Are they perpendicular? What the facts about the y-intercept and the slope and so forth. It doesn't include problems involving just the mechanical parts. So in other words, if we had 2 points, how do you find the slope? And then from that, how would you find the equation y is equal to mx plus b for those particular 2 points? It's just the mechanical parts of drawing them, and are they parallel and perpendicular? We will now consider 4 methods to determine the point of intersection of 2 lines. Our first method is called graphing, second method, elimination, third method, equating, and the fourth method, substitution. These methods require one to be able to solve for x in linear equations. You also must understand positives and negatives. If you feel you're weak in either of these categories, you can go to YouTube and put in RJAINCHELL, and you will find videos on positives and negatives and solve for x to help you with the elimination, equating, and substitution methods. In this particular problem, we're solving for the intersection of 2 straight lines. The first line is y is equal to 2 times x minus 3. The second line is y is equal to -3 times x plus 2. We want to write the 2 in the 2x as 2 over 1. That's the slope. The change in y is 2 and the change in x is 1. The first dot we put in is the -3 on the y-axis. And then from that dot, we come up 2 steps and go over 1, and that's the second red dot on the graph. And then we connect the 2 dots with a straight line. Now to do line 2, we put a dot on the y-axis at positive 2, and then we go change negative 3 to negative 3 over 1. We go down 3 steps, and then we go over 1, and there's the blue dot, and we connect 2 blue dots, and we see that the 2 lines intersect when x is 1 and y is equal to negative 1. So that's the only point where the x's and the y's are the same. As a first example, with the elimination method, we have 2 equations. 2x plus 6y is equal to 19. And the second one is x minus 6y is equal to 2. Now, if you add equals to equals, you obtain equals. And we're assuming that we have a solution, x and y, that works in both equations. The x's and the y's are the same where it's a point of intersection. So, if we were to add the 2 equations, we will obtain another equation that's valid. If you add 2x and x, you get 3x. The 6y and a negative 6y, when you add them, is 0, so you don't have to write it down. And 19 and 2 is 21. This implies, by dividing both sides by 3, x is equal to 7. So that little arrow means implies. Now, x is equal to 7. We'll go to one of our original equations. Well, the second equation, x minus 6y equal 2, is much simpler. Then 2x plus 6y is equal to 19. So we'll plug in the 7 where we see x. So now we have 7 minus 6y is equal to 2. Move the 7 to the other side. Simply change the sign. So negative 6y is 2 minus 7, which is negative 5. Now, if you divide both sides by negative 6, this implies that y is equal to negative 5 over negative 6. A negative divided by negative is a positive. So y is equal to 5 over 6. So we found the point of intersection. That point is x is 7 and y is 5 over 6. In this example, we start off with 2x minus 6y is equal to 23 and 4x plus 5y is equal to negative 5. Now, if we just simply add or subtract the 2 equations, we're not going to eliminate either the variable x or the variable y. However, if we were to multiply the first equation by negative 2, then negative 2 times 2 is negative 4, and then we could perform the elimination. So we do that, and that equation where we multiply by negative 2 is written in red below the 4x plus 5y is equal to negative 5. So negative 2 times 2 is negative 4, negative 2 times negative 6 is plus 12y, and a negative 2 times 23 is negative 46. Now if we add the 2 equations, the x's go away, and we have 17y is equal to negative 51, and if you divide both sides by 17, y is equal to negative 3. Now that we've found y, we can plug that into one of the equations. And so if we plug it into the original equation, 2x minus 6y equal to 23, we got 2x minus 6 times a negative 3 is equal to 23. Now negative 6 times negative 3 is a positive 18. You move that to the other side. 2x is 5. And then if we divide both sides by 2, x is 5 over 2, which is an improper fraction. And we divide 2 and 5, it goes 2 times. You got 1 left. And so that would be 2.5. So we found x is 2.5 and y is equal to negative 3. And that's the point that satisfies both equations at the same time. In our third example, we have 2 equations, and simple multiplication by an integer on one of the equations will not eliminate one of the variables. However, if we do this, if we start with the x, we have 3x at the top. 8 times 3x is 24. Now the 8x on the bottom, we multiply that by negative 3, that would give us negative 24. So we'll do that, and we'll get a set of 2 equivalent equations. Now, 8 times 3x, that's 24x, and 8 times negative 5y, that's negative 40y, and 8 times 7 is 56. Now we do the negative 3 times the bottom. Negative 3 times 8, negative 24x. Negative 3 times negative 9, that's positive 26x. 7y, and negative 3 times 1 1/3. And here's how we're going to do this. Negative 3 times 1 is negative 3, and negative 3 times 1/3 is negative 1. That's using the distributive law. And if you add negative 3 and negative 1, you get negative 4. Okay, so now if we add the two equations, the x's go away, and you have negative 40y plus 27y, that's negative 13y, is equal to 56 minus 4, which is 52. And if you divide both sides by negative 13, y is equal to negative 4. Okay, now if we go back to the top red equation, we would have 3x minus 5 times a negative 4 is equal to 7. That's negative 5 times negative 4 is positive 20. Move it to the other side, so 3x is equal to negative 13. And if you divide 3 into negative 13, you get a negative. 3 goes into 13 4 times. You get 1 left and 1/3, so x is equal to negative 4 1/3. In our first example for the substitution method, we have two equations. 2x minus 5y is equal to 1, and x minus 3y is equal to 4, where these two equations have the same x and y. It's the point of intersection. Now, if we move the negative 3y or minus 3y to the other side, x is equal to 3y plus 4. We can substitute that x into the first equation. So we would have 2 times 3y plus 4 minus the 5y is equal to 1. We have made a substitution. Now, in this substitution, we look at our new equation. It has numbers and y's. There are no x's, so we can solve for y. So we use the distributive law. 2 times 3y plus 4, that would be 6y plus 8, minus 5y is equal to 1. And in one step, we do 6y minus 5y is y, and move the 8 to the other side. We change the side, so y is equal to negative 7. Then we go up to the modified or changed equivalent second equation. X is equal to 3y plus 4. We substitute the negative 7 for y, so x is equal to 3 times negative 7 plus 4, which is negative 21 plus 4, which is negative 17. Here we have two equations, and we're to use the method of substitution. However, we do not notice immediately that either equation is of the form x is equal to something or y is equal to something. However, in the first equation, we have 2x minus 6y equal 12. The three terms, 2x, negative 6y, and 12 are all divisible by 2. So we're going to divide each term by 2. And then what we would obtain is x minus 3y is equal to 6. If we move the negative 3y to the other side, x is equal to 3y plus 6. And now we can substitute that term into the second equation and have an equation just involving y and integers. So 3 times 3y plus 6 plus 5y is 46. Using the distributive law, we have 9y plus 18 plus 5y is 46. Add the two y terms, that's 14y, move the 18 to the other side. Now we have 14y is equal to 28, so y is equal to 2. Substitute that 2 into x is equal to 3y plus 6, so we have x is equal to 3 times 2 plus 6 is equal to 12. Now, we should check our answer in each equation. So x is 12, y is 2. In the first one, 2 times 12, that's 24, minus 6 times 2 is 12, that is 12. And in the second equation, we have 3 times 12 is 36, plus 5 times 2 is 10, and that is 46. So when you check your answer, it has to check in both equations. In the equative method, we set the two y's equal to one another. This is the point of intersection. The x's are the same and the y's are the same. So when y is equal to 3x minus 7, and y is equal to negative 2x plus 4, at the point of intersection, the two y's are equal. So what we have is 3x minus 7 is equal to negative 2x plus 4. A simple method for solving x. Get the x's on one side, get the numbers on the other side, but when you cross equal, change the sign. So move the negative 2x over to the left-hand side. 3x plus 2x is 5x. Move the negative 7 to the right-hand side. 4 plus 7 is 11, so we have 5x is 11. Divide both sides by 5, so x is 11/5, which is 2 1/5. Now to solve for y, it doesn't matter which one we use, we'll use the second equation. So y is equal to negative 2 times 11/5, the improper fraction. Don't use the mixed number. Plus 4. So now we're going to have negative 2 times 11. That's negative 22 over 5 plus 4. 5 goes into negative 22 times negative 4 times. You have a negative 2/5 left. So we call that negative 4 2/5 plus the 4. The negative 4 and 4 is 0. And so our final answer is negative 2/5 for y. In our second example, we have 3y minus x is 4 and 7y minus x is negative 6. We don't have x is equal to something, y is equal to something, but with negative x in both equations, we could move the negative x to the right-hand side and the numbers 4 and negative 6 to the left-hand side. Change the signs. So our new equivalent set of equations is 3y minus 4 is x and 7y plus 6 is x. Set the x's equal to one another. And we have 3y minus 4 is 7y plus 6. We'll solve for y when it's on the right-hand side. So we got negative 10 is equal to 4y. Divide both sides by 4. So negative 10 over 4 is a negative 2.5. Now, we'll use the top equation to solve for x. So when we plug it in, we're going to have 3y minus 4 is x. So 3 times negative 2.5 minus 4 is x is equal to, now let's put it on the right-hand side, 3 times negative 2.5 is negative 5 halves minus 4. So you got 3 times negative 5, negative 15 over 2 minus 4, and then negative 15 over 2 is a negative 7.5 minus 4. The two integers, negative 7, negative 4, that's negative 11. And you have negative 1/2, and we write it as negative 11.5. Some straight line problems. Suppose we're given 2 points, 3, 4, and 5, 8. X is on the left, y is on the right. And we say find the slope of the straight line through the 2 points. Find the equation of the line through the 2 points. Find a line that's parallel to that line, and find a line that's perpendicular. So the first thing we do is define the slope. Slope was defined as the change in y over the change in x. So if we start at 5, 8 and go to 3, 4, the change in y goes 8 minus 4, that's the change, and the change in x is 5 minus 3, that's 4 over 2 is 2. So the slope is 2. Now, given the 2 points, find the equation of a straight line through the 2 points. Well, m equals 2, and we know y is equal to 2x plus b. You can use the point 3, 4, you can use the point 5, 8, but this says with 3, 4, when x is 3, y is 4. So 4 equals 2 times the x value 3 plus b. And so that's 4 is equal to 6 plus b. Move the 6 to the other side, and b is equal to negative 2. Then our equation is y is equal to 2x minus 2. And then we could have the line y is equal to 2x minus 15 is a parallel line. It has the same slope. Okay, one touches the y-axis at negative 2 and the other one touches it at negative 15. Now we have a line where the equation is y equal to minus 1/2 x minus 7. And since minus 1/2 times 2 is negative 1, the two lines are perpendicular. And then if we were asked, could we find a perpendicular line to our given line, so it has a y-intercept of negative 2, we could just say, well, y is equal to negative 1/2 x minus 2. They would have the same y-intercept at negative 2 on the y-axis. So in closing, if we have problems that have 3 equations with 3 unknowns, or 4 equations with 4 unknowns, or 5 equations with 5 unknowns, they can all be done. They are typically done with matrices and determinants. Our problems could have been done with determinants, but it was worthwhile to go through the mechanics on how you would do those by hand. However, with the example shown below, there are 4 equations with 4 unknowns. That would be hard for most people to do these problems by hand, and some people might find it even hard to do them in a spreadsheet because of the magnitude of 17 to the 13th power in the fourth equation. But you could then write code to do this in a spreadsheet, and you would then code in how you find the value of a determinant. So you cannot graph it because you can't graph 4 variables in a world that we live in with 3 dimensions. So you have to have other methods to do other problems. And this concludes our lesson on solving 2 equations with 2 unknowns.